Hello, my beautiful freshmen. I haven't seen you in such a long time. It's been a month, and today the governor came out and said that schools are going to be closed for the rest of the year, which stinks. So, I don't know when I'm going to see you again, but keep up, do the work, and maybe we'll get done as quick as we can with the class. So. Okay, so starting a new chapter, woohoo! This one is actually going to go by pretty quick. Some of these I'm going to put together into one unit, and so this is going to be quick. We're going to have a test, and then we're going to move on to the next. All right, so chapter 12, congruent triangles. Hopefully remember what congruent means. Congruent means that they are the same. They've got the same lengths, okay? And so today, we're going to talk about angles of triangles. There's also congruent polygons, okay? And then these three, proving triangle congruences by, this S stands for side and A stands for angle. So these are different kinds of triangles that we're going to talk about. And so side, angle, side, 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 angle, and angle, angle, side. So don't be afraid. It's fun, actually. So, okay, so 12.1, okay, angles of triangles. And this is a really dumb joke, but maybe it'll help you remember. This obtuse guy is like, I'm not trying to be obtuse, but you're a cute girl. You guys know what obtuse and acute mean, I hope. If you don't, then this will make sense in a few minutes. Okay, so first of all, before we go on to anything, there's some chapters that we skipped in this book, I think probably because you're going to hit it pretty hard in SM2. But I just want to make sure that you understand the notation and how we're writing these out. So, for example, okay, you can name an angle in several different ways. So here's an angle. Okay, this can be written as using its vertex. So this can be angle A. And this little thingy right here is angle. So this can be written as angle A. It also can be written as the number. The number is never out here. It's always in here. Okay, but it's also angle 1. And then you can also name it using its coordinates. Or it's not its coordinates, it's numbers. That's not a number, those are letters. They're letters, okay? And make sure that A is always in the middle because then that shows you which one is the vertex. So this can also be angle CAB, and it can also be angle BAC. Now, if we are measuring an angle, then an M would go in front of all these. So this would be measure of angle A. This is measure of angle 1, measure of angle BAC, measure of angle CAB. So I just want to make sure that you know that before we move on. Okay, so classifying some triangles. This I know is a review. Okay, so this is classifying triangles by their sides. We don't really care what their angles are, we just care about their sides. So if you have a triangle where none of the sides are the same length, it's called scaling. It's a scaling triangle. If you have a triangle where 2 of the sides are the same length, then it is an isosceles triangle. And it says at least 2 congruent sides because actually this has 3 congruent sides, but it is also an isosceles triangle. But if all 3 of them are the same, rather than call it isosceles, we typically will call it equilateral because they're all equal, so equilateral. So isosceles, 2 congruent sides, equilateral, 3 congruent sides, and scaling is when none of them are the same. Okay, classifying triangles by their angles. This is where that dumb joke came in at the beginning of the class. Okay, so an acute triangle is when every angle is smaller than 90 degrees. Okay, so 90 degrees, this is a 90-degree angle, it's perfectly perpendicular. Okay, so if they're all smaller than that, then it's a cute little triangle. Okay, right triangle, it has one right angle, okay? An obtuse angle is one that has an angle that is bigger than 90 degrees, okay? Now let me ask you this, is it possible to have a triangle that has two obtuse angles? So two angles bigger than 90 degrees. So just kind of think about that for a second. Is that even possible? Okay, and lastly, we have an equiangular triangle. It's like an equilateral triangle. The equiangular, it's hard to say, okay, means that every single angle is the same. And that means that the angles are all congruent. And in a triangle, what would that be? They would all be 60 degrees. Okay, get ready for the next one.